Large language models and conversational agents are one of the most interesting technologies to have proliferated recently, specifically agents and their use of tools. So using agents, we essentially just give a large language model access to different tools. And tools can mean a lot of things, as I will explain in a moment. By using agents and tools, we have a pretty much infinite potential in what we can actually do with large language models. They allow us to search web, run code, do maths, and a lot more. Now, we can actually get pretty far with some of the pre-built tools that are available through LangChain. But in a lot of use cases, we will probably need to either modify those existing tools in some way, or actually just build completely custom new tools to fit to our particular use case. So that's exactly what we're going to talk about in this video. We're going to take a look at a few pretty simple examples to get started of tools that we can build before moving on to what I think is a more interesting example of a tool that takes inspiration from the recent Hugging GPT paper and will essentially give our ChatGPT large language model access to another deep learning model, which will allow it to actually look at images and caption them. So that should be pretty interesting. But before we get into that, let's just define kind of what I mean by a tool very quickly. So we have our large language models, and by default, they just kind of exist in isolation. You put in some text and you generate some text, okay? You get some output text from them. Tools can be a lot of different things, okay? But the core is that they are something, this box in the middle here, and that something takes in some, like a string or a couple of parameters, and it outputs a string or a couple of parameters, right? Now, the input to this tool is going to be controlled by our large language model. And then the output actually goes back to our large language model. Okay, so it's just a way of giving new abilities to our large language models. Like you can think of maths, for example. Large language models are very bad at maths, but we can actually just tell it, okay, you're bad at maths, just use this tool and you can calculate whatever you want, right? That is basically what tools are. They are anything that we can plug into our large language model, and that anything is pretty flexible on what we're using. We just need to figure out a way of inputting and outputting relevant information that our large language model can understand. So let's get started with our first example. We're going to be using this notebook here. So there will be a link to this notebook. You can follow along with me if you want. We are going to be using, later on, I mentioned we're going to be using another ML model as one of our tools. So we're going to be using transformers. If you have a CUDA-enabled GPU, this part will run a lot faster for you if you use that GPU. Or if you're on Colab, what you can do is you can go to runtime at the top, change runtime type, hardware accelerator, and make sure you have GPU selected. Okay, so we're going to run those prerequisites. That'll just take a moment for those to install. Okay, once they are installed, we're going to come to our first example. So we're going to build a simple circle circumference calculator tool. Okay, so one thing that large language models are bad at is maths, even when it's something pretty simple like this. So what we're doing is we're importing this base tool class from LangChain tools, and we're using that to initialize our circumference tool class. Okay, so we're going to inherit the main methods from that base tool. Now, there's two important things that we define here: the name, which is just the name of our tool, circumference calculator, and more importantly, the description. So the description is a literally natural language description that is going to be used by our large language model to decide which tool to use, okay? So we need it to describe when to use this tool. So we just say use this tool when you need to calculate a circumference using the radius of a circle, okay? So really clear and straightforward. And then we need to define these two functions. So we have run and arun. Okay, arun is when you would run this tool asynchronously. That I'm not going to talk about that. It's kind of beyond the scope of this video. I will talk about this at some point in the future, but for now we're going to leave that. So we're just going to focus on the standard run function. Okay, so the run function in this example takes a single input radius, which is going to be either an int or a float, and we're just going to return the circumference based on the radius of the circle. Okay, that's all this does. Super simple. I just want to show you like the structure of one of these tools. Okay, so we run that, and when our large language model decides to run this tool, it is going to go to this. Okay. So now we've defined that, let's go ahead and actually initialize our large language model, initialize the conversational agent that we're going to use. So to do that, we actually first need an OpenAI API key. For that, you need to go to platform.openai.com, and your API key, you just put it in here, or you can set it as an environment variable, and this will grab it for you. Then we initialize a large language model. So we're going to be using Chat OpenAI because we're using a chat model here. So GPT 3.5 Turbo. Okay. Temperature, because we're doing some maths, this is pretty important. It is very good to keep your temperature very low. You can think of this as basically randomness. So when you're doing maths or writing code or anything like that, it's a very good idea to keep the temperature or randomness of the model as low as possible, because you don't want it to be random with code. It's going to more likely make mistakes. When you do want it to be more creative, like with creative writing, then you would set temperature up to 1, okay, or higher. And then we initialize conversational memory. So this is just going to allow us to remember the previous 5 interactions between the AI and us in this conversation. The memory key here, we set this to chat history because that is what will be used by the agent down here. Okay, so we're just aligning those two things. I have spoken about that in a previous video on a chat in LangChain in this LangChain video series. So if you want to look more into that, I would recommend you take a look at the chat video of this series. So let's run that. Okay, cool. And now what we want to do is initialize the agent. So we're going to be using, let's run this. So we're going to be using the tools here. So the circumference tool is the only tool we're using, just one, but we need to pass it as a list into the tools parameter of initialize agent. The agent we're going to be using is a chat agent, which means we're using a chat model. It's conversational, meaning it has conversational memory. It uses the React framework, which is like a reasoning and action framework. So basically with this, the model is able to reason about what steps to take and also take actions like use a tool based on those thoughts. And description is referring to the fact that the large language model decides which tool to use based on the description of those tools. All right, we pass in our large language model, set verbose to true because we're developing this, right? So we want to see all the information, all the everything that is happening. If you were pushing this out to customers, you don't necessarily need this. And max iterations. So this is saying how many steps of reasoning and action and observation are you allowed to take before we say stop, right? This is important because it can get stuck in an infinite loop of just trying tool after tool after tool. So we don't want it to do that. It's going to cost money for starters. And then we also have the early stopping method. So generate means that the model is going to decide when it should stop. Okay, cool. So I have already run that, and then we can go to our first question, which is, can you calculate the circumference of a circle that has a radius of 7.81 millimeters? Let's see what it comes up with. Okay, so it gets 49.03 millimeters. Let's take a look what the actual answer is. Okay, 49.07. So it got close, but it's not really accurate. Okay, and if we take a look at why this isn't accurate, even though we've already passed in that tool, it's actually because it didn't use the tool. Okay, it jumped straight to the final answer. So the reason that it's doing that is because this this model is actually overly confident in its own ability to do maths. And so to fix that, we basically need to tell it that it's terrible at maths. So we need to update the system message, so the initial message that the model is given to tell it that it can't do maths. So let's have a look at the existing prompt. Okay, so it's just, Assistant is a large language model trained by OpenAI, designed to assist with a wide variety of range of tasks, so on and so on. Basically, it's telling it, you can do anything, right? But we don't want it to do anything. We want it to not do maths. So I'm just taking that same prompt, but I'm adding a new line in, saying, unfortunately, Assistant is terrible at maths. When provided with math questions, no matter how simple, Assistant always refers to its trusty tools and absolutely does not try to answer math questions by itself. Okay, so we just add this in, and this is enough for the model to decide, okay, actually, I shouldn't just try and guess the answer. I should use my circumference calculator tool. Okay, so we have our new system message here. We need to update our prompt. So the prompt actually contains a system message, some other things, and also the tools that it has available. So we need to create a new prompt using both of those things. And then we set our prompt to that new prompt. Okay, now let's try and ask the exact same question again and see what happens. Okay, great. So it's using the circumference calculator this time. It inputs 7.81. And the output that it returns is 49.07, right? Which is accurate because it is literally running some Python code to calculate that. Okay, so then the output is a circumference of a circle with a radius of 7.81 is approximately 49.07 millimeters, which is much more accurate. Okay, that's pretty cool. Now, in that example, we just use one single input and returned a single output. What if we would like to use a tool with multiple inputs? Okay, we can also do that. So we input these are just specific to the tool we're using. And let me just describe the tool, okay? So what we're going to do is we have our function here, and it's a hypotenuse calculator, okay? We can calculate the hypotenuse of a triangle in different ways. So depending on what we have, right? So if we have the adjacent side and the opposite side, we can use this here. So we take the square root of the adjacent side squared plus the opposite side squared. If we have an angle and one of those sides, we can use this here. So we can use adjacent side over the cosine of the angle, or the opposite side over the sine of the angle, right? So there's multiple options here, multiple ways we can go about this. So because of this, we have multiple inputs, and we actually want the large language model to decide which of these inputs to use, right? So we're telling it, use this tool when you need to calculate the length of a hypotenuse, given one or two sides of a triangle and or an angle in degrees, okay? To use the tool, you must provide at least two of the following parameters: one adjacent side, opposite side, or angle, okay? So with that, that's actually all we need, and this should work, okay? So again, we're not using async run, we're just using run. So we run that, we set our new tools list. In here, we could also include the previous circumference calculator tool, but just, I just want to show you how to build custom tools here, so we're just going to include the single tool. Then we need to create a new prompt, okay? So we create our new prompt with this code here. And then we also, because we just changed the tools that the agent has access to, we need to update those in the agent itself, okay? So we also update the agent tools with our new tools list, okay? And now we can ask the question. If I have a triangle with two sides of length 51 and 34 centimeters, what is the length of the hypotenuse? Let's try. So it goes into the agent execute chain, goes to the correct action, it inputs the correct items, both of the sides, and there we go, we get our answer. So 61.92, so the length of the hypotenuse is approximately 61.29 centimeters. Now let's try this. So rather than giving both sides, and we're now going to give the opposite side and an angle. Okay, let's see if that works. I haven't double checked the logic here, so I'm not actually sure if this is correct, but all we really care about here is showing that the inputs and the outputs are being used correctly by the model. Yeah, it does opposite side and angle, and the observation, so the calculated output there is 55.86, which we get down here. Okay, so that seems to be working, which is pretty cool. Now, both of these are pretty really simple examples, right? Very simple tools. We can do a lot more, and what I want to show you now is actually using tools to give your ChatGPT model or other large language model access to other deep learning models, okay? Because large language models can't do everything, okay? We still use other deep learning models for other things, right? So what I want to do is, well, I'm taking inspiration first from this paper, Hugging GPT, and the idea is that you use a large language model as a controller, and that will refer to other models. These are all like open source models from Hugging Face. So one they have here is this image captioning model. So what I thought, okay, we can try the same. So we're using a different model. I found the one that they used in that paper, or at least in that visual, wasn't the best. So we're going to use I think it's a more recent model called Blip. And we just initialize that, and we'll use that for image captioning. And actually, I didn't even update this here, right? So initially I tried with that model. Let's update this. Cool. So what we do is from transformers, we want to import the processor and the actual model itself. The model we're using is this. And here we're just saying, okay, if we have a CUDA enabled GPU available, use that rather than CPU. Okay, it just means things will be a bit faster. Now the processor, that will process any text if we pass in any text. In this example, we don't, but it does do that. So it tokenizes the text. And it will also pre-process any images. Okay, so Blip expects a specific dimensionality of images. It expects the image pixels to be normalized. So that will be handled by the processor. And then after that, we will pass it to the model here, which is Blip for conditional generation. Conditional generation is just saying, okay, given like some text, it's going to start generating some text, and it's going to this model. I don't know exactly how it works, but I think it uses whatever it sees from the images, right? So it converts them into probably an array or a single vector, and uses that to inform that text generation, okay? So we initialize that, and we move it to our CUDA-enabled GPU if it's available. Okay, cool. So to generate these captions, we actually need an image. So I'm going to start with this image here. I'm going to download it with requests, and then I'm going to open it with PIL, okay? So that'll just create a Python image object that we can then view. And this is also the format that the Blip processor expects to be fed. Okay, so that is loaded. It takes a little bit of time, and it's just a picture of a orangutan in a tree, okay? So let's go ahead and pass that to our processor here. And then what we're going to do is generate some text based on the inputs from this, okay? We also limit that to 20 tokens. So yeah, we use that. By default, I think this actually does already use 20 tokens, but the default value is to be deprecated at some point. So you should set the number of tokens you want here. And then what we do, so this will output, I think it outputs like an array of tokens. So then we use the processor decode to convert those tokens into like human readable text. So let's run that and see what it thinks we have. Okay, processor is not defined. I need to run this. Okay, so then we come to here, run this, and now we should get our output. Okay, so we get, there is a monkey that is sitting in a tree, which, yeah, is accurate. Okay, so now what we want to do is just use this process, this logic in our tool. So that's what we're going to do here. So all this code is basically just what we just went through. So I'm not going to go through that again. All we do is we pass in the URL, so a string, which is where we're going to be downloading everything. So this should actually be URL. Okay, and yeah, looks good. So the description that we're using here is that we should use this tool when given the URL of an image that you'd like to be described. It will return a simple caption describing the image. Okay, so we're just telling it when to use it and what it does. And then we reinitialize our tools list. Okay, run this. And then, so the system message before that we created, it mentioned that thing about, unfortunately, you're terrible at maths. We're not using any math tools now, so we can remove that. That's all I've done here. And we reinitialize our prompt and also reinitialize our tools. Okay, and now we can ask about this image URL here. Okay, so it enters into the agent execute chain, goes straight to the image captioner, passes in the URL, and this is the same image that we saw before. So the observation is that there is a monkey that is sitting in a tree. And so the final answer is, if we come down to here, the image shows a monkey sitting in a tree. Okay, so now our large language model agent can actually tell us what is in a image, which is pretty cool. And obviously we can pair this with multiple different deep learning models like they did in the Hugging GPT paper. Let's try a few more. So I'm going to load this image. Okay, so just have some guy surfing, and if we ask the agent what is in this image, let's see what it comes up with. Okay, so we get surfer riding a wave in the ocean on a clear day. Okay, so again, pretty accurate. I probably wouldn't bet on it being a clear day, but yeah, maybe it is. Okay, so let's come down to the final one, and let's see. This one's a little more difficult. So let's see what it says. Okay, so in this image, you can see there's a baby. I think it's a crocodile with the narrow snout, and it's just in a river sitting on a log. Okay, so we say what is in this image. It goes down as image, gives us the observation that this is a lizard that is sitting on a tree branch in the water. Okay, so it hasn't been specific about whether it's a crocodile or an alligator. It's just said a lizard. So, not perfect, but I think, it's still pretty good. So naturally, I think you can already see there's quite a lot that we can do with tools, and we don't have to restrict ourselves to just a single tool per agent as well. We can just add a ton of different tools and give our agent a ton of options on what it can do. And that's actually what we see in the recent Auto GPT and Baby AGI models that have kind of gone crazy recently. That's what they do. There's just a ton of different tools that these models can use. They have an internal dialogue that it goes through, but a big part of it is actually the number of tools that they can use. So yeah, you can really do quite a lot with these. And I think for anyone that's actually working with large language models and using these, you really do need to be using or need to get familiar with building tools, because they really are a key component of being able to do cool stuff with these models. Now, this is pretty introductory. There is a ton of other stuff that we can cover with tools, and for sure there will be future videos going into more detail, building more advanced conversational agents, and yeah, plenty more. So that should be pretty interesting, but for now we're going to leave it there. So I hope this video has been interesting and useful. Thank you very much for watching, and I will see you again in the next one. Bye.